So welcome everybody to Construction Tech Tuesday. We're really excited about tonight's program with Bob Kelly. We saw the presentation last night. It's really fantastic. I think it'll generate lots of good questions tonight. So we are the Passive House Accelerator, and the Passive House Accelerator is a collaborative online platform for sharing innovation and thought leadership in passive house design and construction. We publish articles and interviews, produce weekly virtual confabs with passive house pioneers from around the world, and we elevate the work and programming of the Passive House movement's leaders, practitioners, and organizations through interviews, articles, social media campaigns, videos, and podcasts. Our aim is to catalyze zero carbon building by accelerating the adoption of Passive House building. With our co-hosts, Kevin Brennan, Shannon Pendleton, Sean St. Amour, and Mark Willey, we produce Construction Tech Tuesday to share the technical, the technique, and the technology of Passive House construction tech. Each week, we welcome guest practitioners to dive into the details of practice with the builder and tradesperson as our target audience. We welcome folks from all corners of the construction and design world to join us each week. So we're very happy you've joined us today. Today was a very momentous day, and so I just want to give a shout out for racial justice. Thank you.
Welcome to the show, guys. Kevin Brennan here from New York City. I am the one of the hosts here of Construction Tech Tuesday. I'm proud to have on a long-standing participant in the show. It's a loyal person who asks a lot of questions and very intriguing evidence here from Chicago. I was excited to be last night, and let's see this show on the road. Thank you all for coming.
Second that, Kevin. Thank you, everybody, for showing up. And Zach, I'm with you for the social justice of the evening, and happy 420, everybody. I'm Shannon Pendleton from Sanderson Design, coming to you, zooming in from the East Coast. And I'm really excited about tonight's presentation because last night my jaw dropped about 3 times. So get ready, buckle up, and over to Sean.
Good evening, good morning, or wherever you're at in the world. I hope you're doing well, and I hope things are happy and potentially high, wherever suits your fancy. Before we dive into Bob's comment, I want to maybe plant the seed. Maybe we can talk about it in the after or the overtime. Sorry, is when you start your high performance project, what spec do you set? Because when I teach the tradesperson course at BCIT, I always said we should look for R20 below slab, R40 walls, R40/60 roof, and R10 windows. What do you do when you first meet with your energy advisor or passive house consultant to figure out where to start in your process? So maybe we can talk about that later. And Mark, over to you, my friend. And of course, that was with a PH.
Friend with a PH. Kevin, Sean, Shannon, thank you. And for everyone that missed it, before we dial into it, I would like you to remember to look in the chat. There's probably a link from someone for the new Passive House Accelerator website. It is worth looking at all day, every day. It's off the charts, and please share it with your network. So blessed to have that available for everyone. I'm also blessed, real quick again, for those that just tuned in. Thanks to Kevin and Aaron and Sean and all the folks at 475, because I got a cool new t-shirt and I'm showing it off. Tonight we're in for a treat. Sit back, put your seatbelt on, your trays in the full upright position. It's going to be a roller coaster again. So my friend Bob, and he's a true friend. He's number 10 of 11 kids. So he's always had to work for quite a bit, but he's also always been surrounded by a lot of support, right? Very similar to our Passive House community. Also, he followed that tradition by raising 9 children of his own, which is just incredible. A heck of a lot easier than running a construction site, for sure. On top of being in the business for 30 years, and on top of inventing products that we need, he's invented the atmosphere in which we can use those products. So you're in for this treat. Bring out your notebooks, bring out your glassware, and please welcome Bob Kelly.
Oh, Mark, thank you for the wonderful introduction. You're a great guy. And I'm really excited to be here. So I'm Bob Kelly. I'm a contractor in Chicago. I specialize in doing repair work, and this has led me into working on masonry buildings with flat roofs for the past decade, really. I had to find a steady source of work, and I found a lot of work in this problem. So here we go with the show. Now, this is the first picture of several that shows very typical structures that we're working on, and this is all over the place. Okay, efflorescence, and the water is flowing through the buildings. It's pulling minerals out. There's multiple examples of water flowing through buildings. Oh, you know what? Every time I see that one, it surprises me. I was driving down Chicago Avenue one day and I saw that building that's probably about 4 or 5 years old. There's another split face block building. Split face block, for those who don't know what that is, it's a textured cinder block, and it was used quite often throughout the building boom. They say almost 100,000 buildings were built in this manner. There are so many combinations of wet masonry, but there's a common theme among all of this work, except the fact that you see, like where the arrows are pointing, where the parapet walls are soaking wet. This is, it looks like limestone, but it's actually a precast stone that's engineered to be porous. It was used as a substitute. Here's efflorescence on the brick of an old building, which tells you off the bat it was ground and repointed with the wrong mortars. They were too hard. Doesn't allow breathing through the joint. It's coming out through the brick. There's water going through capstones. So that's an example that thousands of possible clients in Chicago, right? There's a lot, but this is from the rooftop of one of our early adopters. He was a mechanical engineer who understood that we had a clue as to what happens with a vapor path. So this boils down to 3 things. The first is building science, the second is supply chain, and the third is talent. We are experiencing a 3-way train wreck between these. Building science is not wrong, supply chain is not wrong, and talent is not wrong. Okay, so why do we have all these issues? Supply chain sells to the talent, right? So this photo is kind of funny, but you know, this is turn of the century workers, right? They've lime mortar, low fired brick. Everything's soft and coincidentally compatible. So what's really interesting about this is that, you know, there's how many millions of buildings are built like this and nobody's ever wrong, right? But you combine the two, like the picture on the left, we have soft brick, and you can see where the mortar joints are actually not even disturbed. That's hard mortar. Okay, it's reversing the breathing mechanism on the brick. Now the other picture is actually, you can tell that like a latex-based sealant was applied at one time because there's a water source and it's locking all the moisture and it's allowing the face of the brick to spall off. So basically, you know, water defies gravity. It always moves 3-dimensionally. You get one spot wet, it goes in all directions. So here's kind of a funny introductory video about a project that we were working on. We drilled a hole and we found a little surprise inside. Now, it wasn't too much of a surprise because I pulled the capstone off and I saw a puddle of water, melted down to it, but here we go. We've seen this more than once in these cinder block buildings. There's probably, you know, if I was going to guess, probably a good 10 gallons of water in here. But we've done repairs where we had to cover parapets, do some temporary waterproofing, and had the same condition. So this is going to go on for a little while, so I'll just keep it short. So I think this information, you got to boil it down to, I mean, the way I like to problem solve is how do I get down to the basic components? And these basic components for me are like going back to my Catholic high school education of, you know, Latin, right? We absorb water into materials, which is, you know, let's say you compare that to a glass of water and a loaf of white bread, right? But absorbing changes that whole action to a wetting process, okay? The wetting process means you're surrounding the object in water. It doesn't go through it. So if you think about all the harder mortars that are out there and the hard fired brick, which there's a lot of stories behind why, the economy changed and why manufacturing changed, but the bottom line is things are harder. And we haven't compensated for that, because going back to that picture of the old boys, I mean, we're still doing it the same way: carpentry, sheet metal, and roofing. The 3 goals for repairing a wet building basically boils down to, we want to minimize moisture ingress, we got to maximize the drying effect, and we are constantly trying to keep low resin structural components from rotting. Now, we all know that I'm talking about tree farm lumber. We don't have the old growth trees anymore. They're gone, right? So that's a really important component to how we value our real estate. And the early clients were willing guinea pigs, because nobody knew how to fix their buildings. The first client that we did this to happened to be head of Parkinson's research for Northwestern. And my buddy, who's a home inspector, said, "Hey, remember that one experiment you did? Well, I think I need it here. Let's give it a try." So this is a version of what we're doing now when we waterproof a parapet wall and get it to breathe. We have substituted the mortar joint with corrugated plastics, which, with a crush test we've done, a 4x8 piece of our flashing will crush at 386 pounds. Okay, great. Corrugated plastic is awesome, strong extruded plastic. So we have, on the right-hand side of this wall is a piece of dimple board with high density 1/2-inch polyiso. It's got a fiberglass skin. The fiberglass skin does a great job bonding roof membranes to it. As you move up the wall, we have a piece of counter flashing that is serviceable. It slides in and out of the receiver flashing that's underneath the capstone, and then a typical looking drip edge on the outside. The first layer on top of that wall is actually a polypropylene fabric that's got a perm rating of 108 and will hold the surface tension of water. Okay, so that's the basic nuts and bolts of what we're doing. So now you see a close-up of this photo, and the air flows through, and right at the end of that arrow is actually the sweet spot of this whole system, because the wind testing, I'll show you a picture of that later on, that's where the greatest amount of vacuum is, not down low, but actually up high. That was something that I'd always wondered about, and so now we know. So this is a typical installation for capstone flashing. We take off the stone, you'll see that there's a vinyl flashing. Notice how the vinyl flashing is cut back from the edge. This is really typical. So this is an example of old world school. You gotta bond, they think they gotta bond the limestone to the block or brick like glue, but it's not the case. Water goes through the limestone, goes around the flashing, goes down the wall. Then we grind the wall flat, and we apply a bead of caulk to the top of the wall. We apply the polypropylene fabric, then glue on our flashings, and then a self-adhered drip edge, or not drip edge, and self-adhered flashing material on top of that, in which we set the limestone copings. What I'm trying to display is a common brick wall. This brings to mind a quick story that a really nice project ensued where the mason reground the whole building, common brick, with type N mortar. They did the best job they could with spray foaming the interior with closed cell foam, and then they set the clay tiles on top with mortar. What happened was that the house accumulated a lot of moisture in the air. The walls were almost radiating moisture into the structure through the drywall, even through the foam. So what we did was we took off the clay tiles, took off the mortar, and put a piece of corrugated plastic with the fabric on top of the wall, and just set the clay tiles on top. Well, a couple months later, I got a phone call saying that there was a musty smell coming from behind the casings. Well, there was a rush of water to the roof, and the house dried out, right? The whole building became a linear chimney. Now here's just a close-up of that same detail. That's a job that we completed recently, and it's in the same manner, but this was CMU. It happened to have been coated with the elastomeric paint. We didn't do anything with the roof in that case. The picture on the right is architectural brick. It's 4 inches tall, 8 by 16. That building had inches of ice on the glass every winter until this winter, because we flashed the top with the fabric and plastic, glued the clay tiles on top. They had minimal, if any, ice on their windows. It dried out the openings. That's pretty cool. The picture on the right, wintertime condensation. Picture on the left, I'm sorry, picture on the right, summertime condensation. Picture on the left, frost. So here's another picture of how we treat parapets. This is with a metal coping. Same assembly. The nice thing about the roofing industry is everything's been done the same for so many years that we're able to adapt fairly standard profiles to many different situations. So I kind of like that. A little close up. Now we're going to have the air path again. That's corrugated plastic under our metal coping, and again out. Here's the a wind test that we had performed, a computer simulation where the airflow is coming from the left to the right, and we found that the greatest amount of pressure is on the outboard side of the outboard side of the coping, other side of the wind pressure. In Chicago, they calculated the average wind speed. The average wind speed in Chicago was 18 miles an hour. That created a negative pressure of 7.2 CFM. So if you think about if we can open up our buildings in such a way they're waterproof, there's two-way waterproofing, and you got this kind of draw, well, then your building's going to stay pretty dry. Even if it does get water, it'll have a life cycle. Here's a close-up of our flashing, underneath the corrugated plastic under our flashings. Now, this is interesting. Oftentimes, when we flash the top of a parapet wall, we find a rush of water comes out of the building and wets the outside skin of the brick. I couldn't tell you why it happens or how it happens. I just know that it does happen. The vapor pressure must be so great, it could be pushing the water out, but it didn't rain either one of these days. And you notice on the picture, on both pictures, there's no water traces down below. This is the other side of the building, that the picture on the left where the red brick was up high. We were able to vent that parapet down to the through wall flashing. Everything that's gray, it's not a different color. It's actually the difference between wet and dry. That same building, the walls were grouted solid. My mason looked at me when we took the capstones off and he said, "Kelly, you're pH'd." We expected to see some kind of hollow cavities. It turns out it didn't affect the performance of venting the parapet walls. This is a view of a 8-story building in Milwaukee. We did just this last fall. A commercial crew, they let me design the sheet metal. We put our vent panels underneath. They capped it off. Looks kind of cool with the sun coming up in the morning. And then these guys, we had a really nice discussion about, they were telling me how the steam was rising out of the coping from the condensation. It was a chilly morning, the heat from the building, because it was south facing as well. So, it was really cool to get that professional advice. And by the way, that was Christensen Roofing out of Milwaukee. They're a really talented group. And then the finished job that they did, I'm proud of the work. Okay, so we got another client right outside of Tampa in Bradenton. He built a 9,000 square foot castle. This one's kind of a mind blower. He found me, flew me down, and I was thinking about suggesting maybe 2 widths of block with the gap in between, but he already built the foundation, started the block. And so I took a piece of corrugated plastic and thought, well, maybe we can create a minor airspace and let's see what happens, right? So we wanted to basically defend the interior of the house from any water ingress. But to do so, I thought, well, 4x8 sheets of corrugated plastic, 1/2 inch thick. Let's have a 2-inch cut through the material with the CNC router. We did that to about 500 sheets and lined it up with the mortar joints every 8 inches. We lined the whole interior up past the plywood sheathing and coming out of the roof system in every case. Now, I have to go into a short story. The client happened to be a scientist sitting on the parapet wall and noticed the back of his legs were burning. So he goes down, measures the outside and inside temperatures. It was 95 versus 70. Without insulation and drywall inside the house, turns out we accidentally created a heat exchanger. So, in fact, water vapor, steam is rising out of the building without coming into the house. I thought that was pretty cool too. So here is a little demonstration we did. So we put a fan on it. We had some fog machine going, and it's basically vapor pressure, just giving it a chance to get out. Seems pretty simple, doesn't it? We also employ the use of rain screen materials. I have a favorite. I like Benjamin Opdyke quite a bit. Great fabric, rigid substrate, comes in different thicknesses. I'm not plugging the company. They do a great job. So in this case, the exterior rain screen that we're all used to hearing about seems kind of like new technology, but it's not, right? Just imagine all those old plaster buildings with lath that have an airspace, and rain screens are how many years old? So I think that what we've learned in doing these exercises basically is we want to separate the energy envelope from the structure. Somehow you can insulate, you can do passive all you want. It's a great idea. I think we need to separate the masonry envelope, not the framing envelope. We're talking different animals, right? The masonry envelope, so it can dry three-dimensionally, and then dry buildings conduct less energy than wet buildings, which I've got stories about people blaming their neighbors to have, dogs peeing in the hallway when it was really just mold anyway. So another good example of how buildings perform, there's a dark elastomeric on the outside. On the interior, there was closed cell foam. This created a really intense microclimate. The heat is absorbed with the dark color, heating up the block. And the readings I received on the outside of the masonry structure was like 88% moisture. And on the interior, I was reading 9.7, okay? Now they varied ever so slightly, but you see the cracks here? These are not foundation cracks. See that caulk line was just caulked? I just happened to show up the day the builder tried to cover up this mistake. And you notice how the crack does not extend below the through wall flashing at the floor level. It's because that corner literally filled up with water and cracked from a freeze thaw cycle. The same goes for the caulk that doesn't extend higher up. Makes you think about what's going on. And by the way, that's 2.5, 3 years old now, and had average humidity of about 60 to 70%. It also pinged 100% on the outside in some areas. Another building that's very similar is closed cell on the inside. Now look, I'm not knocking foam. I'm not knocking other materials. It's just the presence of these things in our environment. So this is about 10 degrees below zero. And the columns that are used to grout support the block up 3 stories. Well, they froze and frosted. This wasn't as fortunate. That was a bit of water that froze. So what are our lessons learned here? We know that water migrates through masonry 3-dimensionally. We know that the interior rain screens and ventilation provide 3-dimensional drying effect. Interior rain screens manages vertical vapor and is directed to vented flashings. Wind pressure creates lift force. Vapor pressure seeks release and exit points. A saturated block cracks and blows out when it freezes. Interior rain screens act as a heat exchanger. Also, dry buildings are more energy efficient than wet buildings. So now we're getting into a little down and dirty. This is what we uncover when we pull back the roof membranes. There's a lot of nasty stuff that's going on. The water is saturating the block, and the only thing that can attract the moisture is the cellulose. And this is quick growth lumber, of course. So what do you do about it? Hey, there's my pocket knife. Okay, so this is another condensation event gone bad. Little footnote, conduits that are too high tend to condense and leak into your ceilings. Here's some plywood from another structure, another rotten trusses. Guys, it's endless. Okay. Oh, look at that, nice little growth. Okay, yeah, the white on there was mold, and I'm not a mold expert, but it took me a month to call the industrial hygienist to measure the mold. Well, it dried out. He couldn't pull a lift on this one. He was kind of mad at me. He asked me to call him sooner next time. So kind of let you know what happens to mold when it doesn't have a water source. Here's another building that looks like they might have some truss issues. This was fairly close by on another project. So this is how we get into repairing trusses. We pack the sides, the core with solid blocking. We talked to our engineer, how far back do we need to apply plywood nailed and glued. And then we make our own steel brackets. In this case, that was 3/16 steel, 4x4 with all the holes. We've evolved out of that. Oh, incidentally, this roof system did have open cell foam, and I did moisture testing throughout the roof system. And it turns out it only had affected, this much that we had to excavate. So, foam inboard or insulation inboard of a masonry structure is the plywood's almost never scathed. Okay, it's always on the perimeter where the source of condensation is. Now we make a longer bracket. I just feel more comfortable because I have to sleep with myself at night. Now this is our venting system for the inside of parapet walls. Right now we're running the roof up the entire height of the wall, usually 42 inches or so. There's the flashing that we use on the inside of the parapet that's made to receive the counter flashing to cover the roof termination. This will come clear if you're not familiar with those terms. There's just an engineered pathway for the water vapor right there. So this is a great picture. This is my guy holding the counter flashing, and notice that there's a continuous gap over the roof membrane and over the vent panel. What you don't see here is that there is corrugated plastic in behind the stainless steel sheet metal. So I think what drives me crazy is when you get onto a roofing project and every doghouse and every siding connection is always waterproofing the roof connection. So if it's not serviceable, then you got to take everything apart. And all it takes is like another couple $100 on $1 million house, and just apply your transition metals so that your work is serviceable for the next guy who comes in. And it saves your clients thousands of dollars down the road, and gives you a better waterproofing job anyway. So what are our lessons learned here? We know that passive ventilation within the roof system dries out wet trusses, which is imperative, of course. It maintains structural integrity, extends the useful life of roof materials. Oh, incidentally, I did not mention that whenever we do truss repairs, we always coat the materials with an epoxy that it's entrained with a boric acid. So at least you're leaving behind some sort of bacterial protection, and you're solidifying the wood fibers. It halts mold growth. It improves indoor air quality. You should smell the swamps I've been in, but it works. It also maintains your property value, and our sheet metal profiles will allow for future maintenance. Okay, so this is almost like the other half of our presentation is revolving around truss repair projects and how intrusive they are. If you were to take apart a roof and repair every truss from the top down, trying to keep the people comfortable, you'd blow 4 hours a day, 2 in the beginning and 2 in the backside, just to just to do the work. Otherwise, most contractors will gut the entire 3rd floor of a city type house. So we invented a tent. It's an aluminum structure. We can go 20 to 20 feet wide, 70 feet long. We wrap it with 10 mil boat shrink wrap for those who want to give it a try. You might test your liability policy. You may not want to do that. And this is what the vacuum packed tent looks like. We do put a fan in the tent. In this case, a contractor buddy, they replaced all the trusses in this $5 million house in downtown Chicago. Open cell foam locked in a ton of moisture. It was, I'll tell you later what it was like. There's another project that we've done, truss repairs, early tenting system. Another project we built for a contractor where, there's the sky and the air conditioners. My buddy from Lakefront Roofing in Chicago, who runs it, Chris Spicer. Here's a modified tent. I couldn't build a tent this wide, so we improvised and did a smaller perimeter tent which we were able to hook on the outside of the building, bring down to the roof and seal to the roof, but it was also serviceable. So we could open and close every day. Yet another tent for a balcony. That was quite a repair. Tent facts. You can work, every day, 365, rain, snow, sleet, or dark at night. Normally, clients don't need to move out. So you try to create value in all your projects, right? Minimizes material waste and liability. It reduces labor hours significantly. And it protects your crew, materials, and tools. And you set up, you're good to go every day. We field tested it. We had some wind gusts up to 55. Actually, I think they were greater, but damn thing held up really well. Shrink wrap lasts up to 90 days officially from the manufacturer. And the exhaust fan, which is a 4200 CFM exhaust fan, reduces uplift, but we keep it going 24/7. So our big picture recap is masonry is highly porous. Masonry temperature memory. That's really important. That temperature memory contributes to condensation behind thin membranes. Platform flashings inhibit breathability, which is contrary to how everybody thinks they should be building these days. Passive ventilation dries out wet buildings. Ventilation extends the useful life of trusses and roof materials. Interior rain screens provide a continuous path for vapor release. Interior rain screens also act as a heat exchanger, and horizontal rain screen facilitate vaporize and exit. Lastly, dry buildings are more cost effective to heat and cool, and tents make truss repairs possible and more affordable. So everybody, I thank you from the bottom of my heart to invite me to your show. It's been quite a ride this past decade, and I'm excited to learn more. And there you go.
Bob, thank you so much. Go ahead and unmute everyone. Give a round of applause.
Nice job, Bob.
Fantastic.
Beauty, Bob, beauty.
Beautiful, Bob.
Appreciate it.
Thanks for
Yeah,
taking
way
us
to
to
go.
school, Bob.
Sure, anytime. There's lots to learn. Can't wait. Can't wait to tear up another building.
Yeah.
I like the two-part.
Should we go over to Sean and Kevin here to start things off?
Yeah, no, Bob. I mean, I don't deal with a lot of brickwork, but I know in Vancouver we had to deal with the whole leaky condo industry. We saw lots of this kind of stuff, and so it brings back those horror years of our industry when we just brought in a whole bunch of stuff, thought we could have how to build, and then Mother Nature, like she always does, taught us how she works, and we had to rip apart buildings, and it really affected the construction industry in so much. And so it's great to see a really good example of some building science going on, and just things for all of us to be aware. And again, your excellent skill and your team's work to just really prepare and fix these buildings to last a lot longer. Even the tent detail, I mean, you just kind of threw it in there, but it's so important when we're looking at doing retrofits of building. That detail is really going to come to play when we're looking at fixing the 6 billion buildings we need to do over the next 50, 60 years. That's a simple tool that you showcased tonight that we're going to do, and we can make the whole retrofit process faster because of details like that. So really, thanks, Bob, for sharing. Great
You're
stuff.
welcome. Thank you.
And Bob, I love the tent detail. As an insulation cellulose contractor, I get a lot of calls about insulating the tops of brownstones and row frames, but
Cool.
that tent detail could save me a lot of headache. I turn down a lot of work because I don't want to, cut up the roof, and I'll coordinate it with the roofer. But if we can get that tent system to work, it reduces my liability, and I might be able to do it.
Sure.
So,
Anytime. Love to.
I'll be reaching out for how do we put this together? And I know in my market, driving around the Brooklyn, the Bronx, I see a lot of H-type buildings and old pre-war buildings that you can see that the parapets are the looking glass of how that building is performing. And you can see that all the parapets have been repointed and repaired, and the effervescence coming out the top. And I'm sure there's, just like Chicago, New York has tons of buildings that have moisture issues, and there's a lot to do out there. So thank you for sharing. We really appreciate it.
You're welcome.
I echo everything everyone's saying. You did so much work on this just to get us up to speed last night, and then you've done so much again today. That was an amazing presentation.
Thank you.
Absolutely. Yeah, you wowed me all over again. So thank you so much. We've got a lot of questions in the chat when we're ready to go there. Is there anything else we need to do before we get a couple going?
I have a quick comment. One of the things that I enjoyed, because I've seen this presentation a few times now, and how it evolves is just how our careers evolve, always getting more succinct. You had no condemning of materials or flaws that happened in the buildings you discovered. You simply cited what you saw and offered the solutions forward. That's a very welcoming way to be, because we have to bring in the people around us, not push them further away.
Right.
So the fact that we recognize the vast amount of problems occurring in these buildings, that some of these buildings are only 5 years old, some of them 10. So pretty new buildings. We're recognizing that, and you're shedding light to the techniques and what could be done. I just applaud it, and I boast that everyone should be using that same manner. And enough of me. Let's hear the questions.
Sounds great. We've got our first question from Harvey. Harvey, are you with us?
Yes, I am. Hi, Bob.
Hey, Harvey, how are you?
I'm good. I'm good. Where's the red wine tonight?
Well, there you go.
Ah,
All right, there it is. And I think
Harvey, let's stop for a second. Let's give him a cheers, because he's been drinking water for 39 minutes and he's earned that glass of wine. So cheers,
No.
Bob and Diane. Team effort
Cheers.
over there.
You know
Thank
what?
you,
With
Diane.
that, I don't think I have a
Fill
question
yours
now.
up first, Diane, in case the bottle's running shy.
Yeah.
Yeah, fair enough.
You know what? With that, I don't think I have a question. I can't top that one. You know, you know what, Shannon? I'm passing. Bob,
All
you're
right,
off the
well-
hook this
Wow. Thanks, Harvey.
look what, Bob, you rendered Harvey speechless. Congratulations.
Oh, no, I'm not speechless. I said, I'm passing the question. Let's make sure we're there on that.
That sounds great. Well, we have Scott Farman with a question. Scott, would you like to unmute yourself and ask your question?
Yeah, thanks, Shannon. Hey, Bob, great
Hey, Scott.
presentation. How are you?
Good to see you. Thank you very much.
You as well. I was curious about your take, and it seems like a couple other people were asking about spray foam, and it seems from your investigations, it has been a negative impact to the masonry. But there's other people online, like Building Science Corporation, that say you should spray foam your brick retrofit. So I'm just curious what your thoughts are on that.
Okay, well, I'm just telling you what I've seen is that when you get a porous substrate that's prone to condensation, even if it's been waterproofed and is dry and covered with, if there's a temperature difference, you're always going to have internal condensation. You just can't avoid it. That's why you get those pockets in behind your cant strip on a modified bitumen roof. It's actually behind a fairly dry substrate. And so if you apply the foam to it, I mean, when I've taken foam off of even inside of an interstitial space of a roof system, I've had water weeping out of the CMU. So the concept here that I've come to see is true is that having an interior rain screen, foam all you want, but if you engineer the path of the water vapor down as low as you can, you'll never have a moldy smelling house, and you'll have a high performance structure.
Thanks for the response, Bob. I owe you a call sometime soon. to get out
Anytime,
here.
man. I welcome it.
Thank you, Scott, and good answer. I have a question for you before we go to Devin's question. I noticed in one of your pictures, you took your interior rain screen up to like a ledger board. And I know you were going around framing in a lot of the images, but when you hit the ledger board, what do you do?
Well, that actually goes behind the ledger. Well, what was done was that the ledger was shimmed out with 1/2-inch steel shims, and then the vent panels went through it.
Wow. Okay. Excellent. Nice detail. And
Cool.
while you were giving your presentation, I was commenting on how you could pretty much eat lunch off half of your details. They were so clean.
Thank you.
Thank you. Devin, are you with us? Would you like to unmute and ask your question?
Hi, Bob. Thank you so much. It's really
Devin.
amazing work.
Thank you.
And yeah, it's really terrific presentation as well. Thank you. I'm curious about how, if there's not like significant visual evidence, how the building vapor, the porosity of the building or the moisture content of the building assembly is measured.
Well, the tool I've been using is a FLIR. I think it's called 890. It's got a hygrometer and has air sensing as well. And so, that's the best instrument that I've been able to find to measure that. And then now, when you talk about moisture measurements in masonry, it also relates back to, I'm a huge proponent of ceiling masonry. Now, old masonry, that's a different conversation, but if you do a type N mortar, you're kind of forced to seal that just to mitigate the water. But it's like, I've even asked the chemical company that I use, the chemical is called ChemTreat that we use here. And I know that other contractors will wait the 24 to 48 hours. That's even, they should basically recommended by the company. My mason 20 years ago taught me to let the building dry for 4 days before we apply and do a flood coat. And we've never had a callback from leaks due to leakage from sealant failure. So I've taken some hygrometer readings in different parts of buildings. It seems like if you can get it into the high 30s, low 40s, which is almost impossible in any environment. So low 40s on a hygrometer might be a good measurement using that tool. So that's what I found so far. But moisture content in buildings, otherwise I see 100%, even like the readings that I showed many occasions.
Bob, I love the fact you brought the technology to the show here, talking about the FLIR and it's a surface moisture reader, right?
Yeah, surface moisture.
I always question the fact of those pin moisture meters. How can you say that they're really reading when you can't get them into the brick and the block?
But I think they only measure cellulose, transfer of energy through cellulose, right? Moisture. But
yeah.
The other testing that we do is Rylam tube testing. Rylam tube is like a clear plastic pipe. If no one's ever seen one, fill it up with water. Water can go in. Could you find it?
I can, but I don't know how to share it.
Anyway, we got a picture of a Rylam tube test, but
to everyone.
Well,
how useful have you found the Rylam tube testing to be in terms of like one area of the building versus another? Or is it fairly consistent, or if it's a similar age, or is it vary based on, say, the orientation or something like this?
Yeah, I try to do like a blanket approach to a lot of these jobs because you can't pinpoint, and so I try to get the hard places to reach to try to measure the moisture and then see how porous it is, because my ChemTreat rep will come out and do Rylam tube test before and after to make sure that it holds, and they can judge by just the flow rate by how much material that you're going to need to use to waterproof. I hope that answers your question.
It does. Thank you very, very much.
You're welcome.
Well, we have also a question from Paul Eck. Paul, are you with us?
Somehow I got into the questions. I didn't really have a
how
question,
are you? Good to see you, buddy.
Hi, Bob. Hey, good to see you.
It was a farming question with a PH, right?
Yeah, so Bob is my building science neighbor, everybody, and I recommend that you seek out these products and don't worry about how much they cost, just buy them, okay? Because saving a building rather than having a building falling down, it's priceless. What I do, Diane?
Very good. Don't tell him how much I paid you.
So Bob, his real question was, what kind of mushrooms
20.
can you grow?
I'm sorry, what kind of what?
What kind of mushrooms can you grow? He was.
Oh, I don't know. I'm sure that's a special skill.
Well, by the
No, really, this is building science for sure, you guys.
Well,
definitely, this is all about building science.
Yeah.
Thanks, Paul.
Thanks, Paul. It's great seeing you.
Shannon, I'm pretty sure that orange mushroom was psychedelic.
Well, I'm going to ask a couple of questions for Patricia because I think she is not available to use her mic right now. And her questions were, what about closed cell foam? And the second question was, what about EPS board on the outside of block?
Well, okay, so you're talking about, two different animals, right? So let's say closed cell foam. What about closed cell foam? Closed cell foam can be applied just like any other insulation. I just like to maintain that gap, and you don't need much. So, although one thing that I've heard from a spray foam installer is that there might be enough heat created by closed cell foam that it could melt the plastic that it's applied to, but I don't know enough about that process. So it's like when I do any work and I need foam, I tend to go to 4x8 sheets of foam board, and that way it's kind of a cold applied method. So, I'm sure that the closed cell foam has got a lot of great applications. I just don't want to go underneath the roof deck of the plywood. I want to keep it isolated, almost like a cap, and let everything else kind of flow around it and above it. So I'm not sure how you do that. I think you'd probably want to use like rock wool in the roof system. We've had, we did a job. One of those tent pictures was actually a project where we rented a 35-foot penthouse, and there was a 25-foot deck down low and behind this upstairs area. Now, bear with me because it's a lot of description. So we did the penthouse venting, and one winter we came back the next spring. Well, it just so happens that 16 feet down and 25 feet back, the crown molding shrunk 3/4 of an inch. What happened was that the water actually traveled this way and up through the penthouse. So that was 3 or 4 months of drying in that structure. So these are all things that we're learning. I mean, it was uninterrupted flow of water vapor. It was kind of crazy. So, and then as far as like covering the outside of a building, well, now you're getting into a completely different animal. You're using your masonry as your nailer, and you're putting your foam on the outside. Yeah, you can totally control your environment that way. So now at that point, now you're encapsulating everything and sealing everything up. It's just, for me in my world, it's not even a possibility with the lot lines being, half inch back from, or the houses being a half inch back from the lot line.
Shannon, could I do a follow-up on that? This is Patricia.
Sure, Patricia, go ahead.
You have to vent when you use the EPS on the outside. I've got 3 inches on the outside, and I've got battens on the outside of that, and then the siding. Do you need to leave any venting between the EPS and the building, or can it just be adhered?
Well, I think it would be adhered, because now you're creating an insulation situation, and it's truly, you're kind of like you're using the masonry as your substrate. And I think if your dew point can't reach into and change the temperature of your masonry drastically from the outside temperature, it sounds like you're pretty safe.
Okay, thank you.
You're welcome.
So we have Jeff Spiritos up next.
Hey, thanks a lot, Shannon. Bob, I got to tell you, that presentation scared the PHIT out of me. I'm not a brick guy at all, but to see all of that deterioration, I mean, I know pretty much what water can do, but I've never seen anything like that. And I really wanted to ask Kevin and Michael Ingley, for all your brick passive house retrofit, have you seen anything like that stuff when you take on a project? If not, why not?
I honestly see, I'm not involved in the roof demo a lot of the time, so I am not privy to see the damage to the roof sheathing. Most of the projects we work on, I hear that the roofs are in pretty good shape on the brownstones. What I do see a lot is the brick and the limestone around the windows that over time has deteriorated where the window once sat. Like you could imagine that it was one square and then all of a sudden it's fallen apart. I do see that very often in the work, and we have to repoint and get that all a square so that we can do it can receive the window. Mike, are you on? Do you have any insight?
Yeah, I mean, our roofs are destroyed sometimes. I mean, sometimes they're in good shape. The old asbestos roofs, when I've got like 8 layers of roofing on it, when we get in, once I get down to the pine boards below, They're really, really nice, and very often not great. But if that roof has been replaced at some point, and they at some point 10, 20 years ago, they removed it and they put down their own roof, they're history. And we got lots of problems. And I'm right there with you, Jeff. This presentation scares the crap out of me. I got to tell you, I think about this all the time on all of our masonry projects, on all of our passive houses. We've got all this old brick, all these old joists, all these weird roof conditions. And it's why I have Kevin on the job all the time. It's why I have John and Ed on the job site all the time, because I'm just assuming we're missing something that you're describing. And it's a scary thing for these old buildings.
Well, Michael, Bob and I are going to pack up the tent and join you and Kevin and Ed and the crew in New York. I think now is a good time. We'll go to the mentor portion, Bob. Then we'll break to Zach, and then we have a special guest. So, Bob, please share your mentor and acknowledge the person that paved the way for you in the business, brother.
Okay, I'd be glad to. And
go back to that.
I'm going to click on here. Give me 1 second.
Yeah.
And go down one slide.
Okay.
If you can make it.
Here we go. This gentleman's name is Victor Friese. Good old boy from St. Louis. He kind of took me on as a son in some respects. I used to meet him in the shop early morning. We'd have bowl of Cheerios. He'd teach me how to do estimating and read blueprints. And sometimes, he even had a softball team with all the guys. We had about 20 carpenters. We all turned all of our own ash blanks into baseball bats for our softball team. So he was really he put in the foundation. He trimmed them out. He ground the knives, built the cabinets, did the roofing, soldered the copper gutters. The guy was amazing. And so I've patterned my whole business after his techniques. So, he's gone to the great reward, but, to this day, I think of him quite often. So thank you for asking.
That is one of the best mentorships we've heard so far, from the Cheerios to the copper to the ash bats. Zach, you have the mic.
All right, thank you. Yeah, that was wonderful. So all of the work that we do at the Accelerator is thanks to support from our sponsors. And when we talk about our founding sponsors, we're talking about the major supporters of the Passive House Accelerator that not only give us sustaining support, but have done so early on in the development of the Accelerator. So they've really helped the platform launch. And it's a special group of folks, and we're deeply grateful for their help. And we just closed this sponsorship category out, completed the circle with the addition of Rockwool as a founding sponsor. So I wanted just to mark this moment. We'll have announcements next week about some other stuff coming. But these founding sponsors are a big reason that we are able to do this programming tonight. So those founding sponsors are 475 High Performance Building Supply, Backstingui Architects, Glavel Foam Glass Gravel, Minotaur All-in-One HVAC and Dehumidification, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwool, Stocorp, and Zola Windows. Our stakeholder partner is NYSERDA, and our patron sponsors are Aero Barrier, BR+A Consulting Engineers, Brennan Airtightness and Insulation, Innotech Windows and Doors, and US Engineered Wood T-Stud. So we have a great episode of the Passive House podcast out right now. It's with Tom Isley, who is the policy advisor with New York Passive House. He was recently with the New York City's mayor's office, working on sustainability and resilience around buildings. And he talks about Local Law 97, which is this amazing piece of legislation in New York City that is capping greenhouse gas emissions in all buildings of 25,000 square feet or larger in New York, and bringing that cap down lower and lower toward 80% lower than a baseline by 2050. So it's a great conversation about that and how important that is for adoption of Passive House. And we also touch on the policy summit that I'll talk about in a little bit. Tomorrow, we have a really special Passive House happy hour episode. We just had Ryan and Lewis run through this presentation. It's about Sendero Verde. It's also about Cornell West. I have racial justice on my mind. Cornell Tech Tower, and 2 other projects, and they pack in a lot of awesome information about larger passive house buildings, and it's one that you really don't want to miss. It's going to be a really great happy hour tomorrow night. And then next week, Construction Tech Tuesday, we have Monadnock Construction talking about a multifamily passive house, and looking forward to that. I know that Kevin is well versed in the work that they've been doing, and it should be a great presentation also about a big passive house building. And then we have Zaina Taljay who's a developer, talking about developing passive house and net zero condos. My son is trying to get me to give him screen time. No, thank you, guy, not right now. So that should be great. And then our Passive House Policy Summit is April 26th, which is next Monday. Please register and join us. We're getting great registrations. We also have a really fantastic lineup of presenters who will be talking about examples of great passive house policy from British Columbia, from Massachusetts, from New York, from Washington State, and from elsewhere. Our claim at the summit is that all new buildings, or at least virtually all new buildings, can and should be passive house now, and we have the policy solutions to help make that happen. So let's all make that happen together. Thanks. I'm done. I know that was a lot. Thanks everyone for being here.